Hi there everybody. So today's topic is about chemical bonding. This is the second chapter of your syllabus. So previously I have told you about the periodic properties, periodic table, and there I have explained all the things like electron affinity, ionization potential, metallic character, non-metallic character, and also I have given you a brief idea about metal bond and covalent bond. So in this chemical bonding we are gonna to learn this in detail. So the first thing, that chemical bond. So I have also told one thing, that everything in this world wants stability. It means that why the atoms, metals and non-metals, they are losing or accepting one electron or electrons to their outermost shell. Why they want to gain electronic configuration like the inert gases. I have given you also the reason why, because inert gas has the complete outermost shell. If we just see the electronic configuration of helium, we'll find that atomic number of helium is 2. That's why its electronic configuration is like that. So in this case, the K shell is fulfilled. And again, if we move on to neon, we'll find that its atomic number is 10 and it has electronic configuration 2 and 8. Similarly, its Al shell, complete octet. There are 8 electrons, it fulfills the octet rule. So, and we have also found that every elements with their complete outermost shell do not react, or they are least reactive. So, and any particle, anything in the world reacts only when they want some stability. And when they get the desired stability, they will definitely don't react. Okay, so this is the thing, that the stability and energy. And I have also told you, as the energy releases and the stability also increases. Okay, for example, so suppose you are not at home, and in this summer you have done a lot of work outside, and there you come home and you want rest, because now you are sweating because you have got a lot of energy. That's the heat in its heat form. That is why now you want rest. So when a molecule has its high energy, or any elements have its high energy in the form of heat or maybe other form, so then you can say that this element is in its low stable state. So if you want to rest, and there after some time you feel relaxed, now I am just completely relaxed, so it means that now you are in a stable condition. Similarly, every element react with another element only when they want some stability. Okay, and after they gain their desired stability, they will stop reacting with other elements. So that is why your helium, neon, they have already gained a lot of stability. That is how they don't want to react with other elements, and thus they stay as inert or unreactive. Okay, so chemical bond. What is chemical bond? So the force of attraction between any two atoms in a molecule to maintain stability. So here again comes the term stability. So I have told you that why metals, or you can see the left side atoms of periodic table won't lose one electron from its outermost shell, and the right side elements accept electrons to its outermost shell. Okay, so I have explain you everything. So only the main game is to get electronic configuration like inert gas, and this is the reason. So what is chemical bond? Just told you that the force of attraction when two elements react with each other to gain such a stability, they form a bond between them. This is a chemical bond. Actually, this bond is nothing but the force of attraction between them. Okay, so here you have 3 kinds of bond. First is electrovalent bond or ionic bond, and then covalent bond, and then coordinate or dative bond. Okay, so what is electrovalent bond? Suppose we are taking an element from group 1, that is sodium, and also taking an element from group 17, that is chlorine. Okay, so sodium, it has electronic configuration 281. So to gain electronic configuration like neon, it will lose one electron from its outermost shell and thus become sodium plus. Again, as chlorine has 287 electron and it want it to get electronic configuration like argon, because if it's gain one electron, it will have electronic configuration 2,8,8. That is electronic configuration of argon. So yeah, you can say that sodium chlorine can also, you may have questioned that chlorine can also donate 7 electrons so that it gain outer electronic configuration like neon. But every element wants to stay in the position like the nearest inert gas element. Okay, that is the reason chlorine always wants to have electronic configuration like your argon. Okay, so when so this symbol is to indicate the electrons of sodium. And I have just draw a picture here. This is the orbital picture. So sodium has 2 electrons in the first shell, then 8 electrons to the second shell, and third shell have only 1 electron, and chlorine has 2 electrons in its first, 8 in second, and 7 in outermost shell. So now sodium is donating 1 electron to the outermost shell of chlorine, and thus sodium becomes sodium plus because it is losing 1 electron. That is why it effective nuclear charge increase. That is why it gets some positive character effectively. And similarly, chlorine, as it's accept electron, and as electron has actually negative charge, so gaining 1 electron it becomes negatively charged. Okay, so now they are positive and negative charge has formed within the sodium chloride. Okay, so now there will be a chemical bond, and actually this bond is nothing but the Coulombic force of attraction, because we know that two opposite positive charge always attract each other, while two similar charge will always repel each other. That is why there is a Coulombic force of attraction between them. So this is the orbit structure of ionic bonding. And I have also want to say that electrovalent bond or ionic bond is generally formed between metal and non-metal. So metal, you can say that the groups of 1 to 13, and non-metal of group 15 to 17, because 15 to 17 they are generally non-metal, they have less metallic character, again more non-metallic character, while metals of 1 to 13 has metallic character. And between them you can say that from 3 to 12 there are transition metals. They act like somewhere they act like metals, and somewhere they act like non-metals. So that is why we will not consider them. Only groups 1 to 13 will act as good metal. Cations must have low ionization potential. Okay, I have told you why. What is ionization potential? Ionization potential is the energy required to remove 1 electron from an atom in its gaseous state from its outermost shell, and to convert it to a positively charged gaseous cation. So cations must have low ionization potential. Low ionization potential means it requires less energy. That means it must have what? It must have good atomic size. Only then the outermost shell electrons will loosely bind, and then it will require less energy to remove the electron from its outermost shell. Anion must have high electron affinity. So what is electron affinity? I have told you that electron affinity is the energy released when one gaseous atom gets 1 electron to its outermost shell and thus become a gaseous anion. So here chlorine, you can say that chlorine accepts 1 electron from sodium and thus become its Cl minus, and it get a lot of stability, and that's why it is releasing more energy. I have also told you that if some molecule or element just release more energy, that means it gets high stability. High energy means if any element have high energy, it means it has low stability. So chlorine, when accepts electron, it's releasing energy, and thus it's getting more stability. Okay, so large electronegativity difference between atoms. Electronegativity is the tendency of atoms to attract the outermost shell electrons towards itself. And large electronegativity difference between atoms, also you have to maintain that left side element of periodic table has less electronegative. They are mostly electropositive element because they want to just lose one electron from its outermost shell and to become a positively charged cation, and while thus right side element of periodic table wants to gain one electron to its outermost shell and thus become electronegative element. Now the question is, what is electrovalency? Electrovalency is the number of electrons that an element loses or gains to form a electrovalent bond. So here the electrovalency of sodium chloride is 1. Now other compounds have also a tendency to form ionic bond. So in this case, for example, MgCl2, you can say calcium oxide, they both form ionic bond between them, because here Mg is metal while Cl2 or chlorine is non-metal. That is why they will form ionic bond, electrovalent bond between them. Here is the electron dot structure of MgCl2. These two symbolizes the outermost shell electrons of Mg, while the 6 electrons or 6 dots around chlorine symbolizes the outermost shell electrons of chlorine, and these two. And when Mg, and you know that when their Mg and Cl reacts with each other, so Cl can only accept one electron to its outermost shell, but Mg has to give 2 electrons, and that's why, and because in this way it can only get electronic configuration like neon, and thus it requires 2 Cl to get it 2 electrons respectively, and thus it becomes Mg2 plus as it is losing 2 electrons from its outermost shell, and as it needs 2 Cl, so there is 2 chlorine atoms, chlorine anion is formed. Okay, this is the electron dot structure of MgCl2. I hope you understand, and you can also draw other electronic dot structure of NaCl or CaO at your home. So what is the electrovalency of Mg2 plus? It is 2, because here the magnesium atom donating its 2 electron, and the electrovalency of chlorine minus will be 1, because each chlorine atom, here there is 2 chlorine atom and they both accept 1 electron each. That is why their electrovalency of chlorine atom will be 1. So I hope you understand what is electrovalency and how to draw the electron dot structure of different ionic compound. So next, move on to the question. Divide the reaction into oxidation and reduction. Sn plus 2 Hg2 plus Sn4 plus Hg2 2 plus. Okay, so what is oxidation and reduction? I have told you earlier that where there is the increase of oxidation state. For example, here Sn plus 2 has oxidation number plus 2, and here Sn plus 4 has oxidation number plus 4. It means there is an increase in oxidation number from plus 2 to plus 4. So the first thing we get that from Sn plus 2, as it releases 2 electrons and become Sn plus 4. So this is the oxidation reaction. This can be written as like that. As it is 2 electrons. So definitely there will be some atoms that has to accept these 2 electrons, and these 2 electrons will be accepted by Hg2 plus. And Hg2 plus, as there is 2 Hg plus, 2 Hg2 plus atom, so each will accept 1 electron and thus become Hg plus. Hg plus in this way. So this can be written as Hg2 2 plus. As there is 2 Hg atom, that is why we are writing 2 is 2 positive charge, hence its charge will be 2 plus. So there is a decrease in oxidation number. Okay, because you can see that in this case the oxidation number of Hg atom was plus 2, but here actually this molecule has this structure. That is why here this oxidation number is decreases from plus 2 to plus 1, as this Hg plus atom has oxidation number plus 1. So I hope you understand this question. So next move on to what is covalent bond. Covalent bond is the mutual sharing of one or more pairs of electrons between them. Each atom contributes equal number of electrons. For example, I have told you that chlorine atom, it accepts electron because it's want to get electronic configuration like argon, and thus it becomes stable. So to accept electron, it must have someone that will donate its electron. But how chlorine gas, Cl2 gas, is formed? And these chlorine gas form in this way, where two chlorine atom comes together and they share each electron from their outermost shell and thus form a covalent bond between them. And here both atoms share these two electrons along a bond and with equally. They share it equally. Okay, so this type of bond mainly formed between non-metallic compounds. So there are covalent bond can be classified into three categories. You can see that this is single covalent bond, then double covalent bond, and then triple covalent bond. So what is single covalent bond? Let's have an example of HCl, where H, hydrogen, has one electron to its outermost shell, and Cl, chlorine, has 7 electrons to its outermost shell, and hydrogen and Cl comes together and form a covalent bond between them, and thus we produce HCl. Similarly, carbon and oxygen, where oxygen has 6 electrons to its outermost shell, carbon has 4 electrons to its outermost shell, oxygen has 6 electrons to its outermost shell, and thus they come together and form a covalent bond between them. Now the question is, why here carbon cannot donate its 4 electron to get electronic configuration like helium? Because it cannot donate its 4 electron, because it requires more energy. As carbon has relatively small structure with effective nuclear charge, that is why it requires more energy, very high energy, to remove the 4 electrons from its outermost shell. That is why it do not or never participate in ionic bond formation. It always forms covalent bond with other molecule. So here covalence of oxygen is 2 because it is forming 2 covalent bonds with carbon. That is why each oxygen atom will have the covalency 2. Similarly, here the covalence of carbon will be 4 as it is forming 4 covalent bond with 2 oxygen atom. Next, move on to triple covalent bond. Similarly, here carbon have 4 outermost electrons. So here 3 covalent bond will be formed between 2 carbon atoms and 1 with the hydrogen atom. So this is the structure of acetylene, where the covalency of carbon is what? 4, as each carbon is participating or forming 4 covalent bond with carbon, another carbon and hydrogen. Okay, I hope you understand. Now what is polarity? Polarity is the distribution of electronic charge over the atoms joined by the bond. So here you can see polar covalent bond between HCl molecule. Here, as chlorine has high electronegative characteristic, that is why it attracts the bonding electron pair towards itself, making the hydrogen atom quite positive character, and it gains a negative character due to this attraction, and thus there is a separation of charge between the 2 atoms, hydrogen and Cl, and thus create a dipole. That is why HCl is called dipole molecule. Similarly, same things happens with water molecule, where oxygen being higher electronegative, it attracts the bonding electron pair of OH bond towards itself, and thus it gets some negative character, and two hydrogen atom gets some positive character, and thus create a polar covalent bond. And in non-polar covalent bond, there is no chance of generation of such polarity, because here both atoms between which the covalent bond exists have the same electronegativity. Here in acetylene molecule, both are carbon, and between them there is free covalent bond, and they have the same electronegativity. That is why there is no polarity in between acetylene molecule. Next, move on to ionization. So ionization is the process by which covalent compounds are converted into ions. So here you can see HCl in aqueous medium, it becomes H plus and Cl minus, because in aqueous medium, due to water being a polar solvent, it reduces the electrostatic force of attraction between the molecules. That is why in a aqueous medium HCl, the atom H and Cl, the attractive force between them get reduced, and thus they ionizes, and this process is called as ionization. Now I hope that everything is clear about ionic bond and covalent bond, but I'm also just giving you a gist of all the things, that in ionic bond, atoms, cations, should have 1 to 3 electrons in its outermost shell. How? That is sodium plus, Mg2 plus, Al3 plus. They lose 1 electron, they donate 1 electron, 2 electrons and 3 electrons respectively, and get electronic configuration like the nearest inert gas, neon, and thus get stability. That is why they ionizes and forms ionic bond with the non-metals compound. Similarly, in covalent bond, both atoms should have 4 or more electrons in its outermost shell, except hydrogen, beryllium, boron, aluminium, etc. Because here hydrogen, beryllium, boron and aluminium each have 1, 2, 3 electrons in their outermost shell. Now, only gaining or donation of electrons occur in ionic bond, while only sharing of bonding electron pair is possible in covalent bond. Again, atoms, cation and anion will have large electronegativity difference. I hope you relate this what I have told you earlier, that how their large electronegativity difference, it determines their bond characteristics. What will be the bond between two atoms will depends on its electronegativity character. If there is a very low or zero electronegativity difference, then the two atoms will create covalent bond, while if there is a large electronegativity difference, there will be ionic bond between the two atoms. Okay, metal and non-metal atoms reacts. Why they react to form ionic bond, I have told you. Non-metals react because they want to accept electrons to get inert gas-like configuration. That is why they only react and form covalent bond. Again, one thing, that cation will have low ionization potential, anion must have high electronic affinity. I have explained you also this. So both the atoms should have high electron affinity, electronegativity and ionization potential, because only then there will be sharing of electron pairs is possible. Again, in ionic bond, as the cation will have low ionization potential, that means it has more tendency, or it easily donates its electron, and anion having high electron affinity, it will easily accept this electron and thus form a ionic bond in between them. So electrovalent compound and covalent compound. Electrovalent compound are hard solids of ions. Strong electrostatic force of attractions exists between them. And covalent compounds, gaseous, liquids or soft solids, weak force of attraction. As in electrovalent compound, there have cation and anion. That is why there is a electrostatic force of attraction, Coulombic force of attraction between them. As we know that two opposite charges will always attract each other, and this attraction is really very strong. That is why most electrovalent compounds are of hard solids of ions. They have high boiling point and melting point, definitely, as their electrostatic force of attraction between them is very high. So definitely it will require more energy to break an ionic bond, and thus it will have high boiling point and high melting point. But covalent compound, as they have weak force of attraction between their molecules, so it will require less energy to break the bonds and thus low boiling point and melting point. Next, it conduct electricity in water because the attractive force between them is decreased in water and thus produce free ions. Whereas covalent compounds is non-character, no, it has no free ions. Their ions dissociate and migrate when an electric current passes through them in their molten or aqueous solution state. Do not dissociate, but polar compounds can. Example, HCl, H2O, H2O plus and Cl minus, will see this. Soluble in water but insoluble in organic solvents, and soluble in organic solvents and insoluble in water. These 3 points have only one answer. As water is a polar compound, it decreases the electrostatic forces of attraction, resulting in free ions in aqueous solution. Hence, they dissolve and they conduct electricity, because in water it produces free ions and thus they conduct electricity. And while they are soluble in water, as they are getting separated, the ions are getting separated as the attraction between them is decreasing in water, so they are soluble in water. But insoluble in organic solvents, because in organic solvents are non-polar. So as there is so that is why they are insoluble in organic solvents. But covalent compound is exactly the opposite of electrovalent compound. That is why it do not conduct electricity in water, because there is no separation of ions in water medium of covalent compounds, and do not dissociate, but polar compounds can. And I have told you the polar compounds like HCl, because in water there is a separation of charge H plus and Cl minus. That is why they conduct electricity and also dissociate. And soluble in organic solvents, they are insoluble in water. Soluble in organic solvent, because organic solvent is non-polar. That is why they are soluble in organic solvents. Now move on to the coordinate bond. In coordinate bond, let's have an example of H and oxygen. H, hydrogen, has 1 electron to its outermost shell, and while oxygen has 6 electrons to its outermost shell, and thus it produced a covalent bond between oxygen and 2 hydrogen atoms, where oxygen share its electrons with 2 hydrogen molecule and thus produce a covalent bond. But here you can see that here oxygen has 2 lone pairs. Actually, a pair of electrons which is not shared with any other atom is known as lone pair of electrons. So here oxygen do not share its electrons, these two pair of electrons with any atom. That is why they are the lone pairs of oxygen atom. So definitely now oxygen can donate this electron to anyone. So it can donate this electron. That is why, for example, let's there come H plus as an acceptor, and now hydrogen has no electrons to its outermost shell. That is why it has a strong tendency to accept electrons, and thus it accepts the 2 electrons from oxygen and thus produce hydronium ion. So here actually hydrogen is not sharing its electrons with oxygen, but oxygen is sharing its electron pair. Here is the complete share of electrons from oxygen atom to hydrogen atom. That is why this type of bond is called coordinate covalent bond, where there is a sharing of lone pair of electron between 2 atoms is occurred. So there is some examples of coordinate covalent bond. Examples of compounds having both electrovalent and covalent bond is NaOH, where this is electrovalent bond and this is a covalent bond. Here you can also see in CaCO3. Similarly, there is an example of compound having both covalent and coordinate bond is sulfuric acid, where there is 2 covalent bond between sulfur and oxygen, and there is 2 covalent bond with 2 coordinate covalent bond with 2 oxygen atoms of sulfur. What happens, how happens, I will make another video of it. Now how this kind of bonds are formed between those molecules, I will tell you in another video. So this is all about your second chapter, where read about chemical bond, electrovalent bond, covalent bond and coordinate bond. So for electrovalent bond, I have told you two examples of NaCl and MgCl2. And for covalent bond, I have told you an example of chlorine molecule HCl, then CO2, and then acetylene. I have explained all the things. If you have any doubts and queries, you go direct to the comment section, ask me. That's it. That is it for today.